Hey everyone, welcome to a quick info video on this is number 4, on average atomic mass. So right now the background information gives you some bolded words and the situation that you are supposed to be solving. You'll find your first question right here, and if you're not sure, all these bold words can be found, if you haven't got to them yet, on the helpful information sheet. So this sheet will be made available to you in lab and has a whole bunch of info on protons, neutrons, electrons, isotopes, mass number, percent abundance, all the stuff that you will need to complete this lab will be given to you as well. So once you've gone through that, we're focusing on this element right here. We have 3 different versions of it. So what you're going to do is we have the mass for each of them, determine the mass number, and from that, the number of protons, neutrons, and electrons. Your hint right now is that your protons were given to you in the top part of the lab. So between that and your mass number, you're able to find out the rest. And it asks you about protons, neutrons, electrons, and how they change throughout an isotope. Next is you're going to be calculating the percent abundance. So the whole point of this lab is to figure out first how to calculate average atomic mass, but kind of taking a step back and figuring out, well, how did we get there? Where did those numbers come from? So here is a sample of marshmallow in nature. And so your job is to first calculate the percent abundance. So you want to calculate it for each of them separately, for the plain, for the stripes, for the polka dot ones. So your first job will be to count all of the plain ones, all of the stripes ones, all of the polka dotted ones to give you your number of samples, and you'll come up with a total. Now, let's just say this is A, B, and C, and your total is D. So part over whole, you would just do A over D, and it gives you some number. For the next one, B over whatever that D was, giving you your answer. Now we want you to round your answer to 5 decimal points. Then, whatever your answer is here, you're going to multiply it by 100. So you'll get a much bigger number here. And this column is the same thing. Again, just make sure you are using 3 decimal places. Now with that, all 3 of these numbers should add up to 100 because you're saying of all the versions of the marshmallow element that exists, so many percent is the plain one, so many is the striped one, so many is the polka dotted one, but altogether that should add up to 100. Great way to kind of check yourself. Now, this percent abundance that you've calculated for each of these 3 things, that goes in this column. So whatever you put there goes there. If you put, let's say, call this square, you put square there. If you put triangle there, triangle goes there. You put circle there, circle goes there. Now your next job is to write it as a decimal. And so in order to do that, let's give this a number. Say this was 25.2%. In order to convert to a decimal, you move it 2 spots over to the left. So you would get 0.252. Again, those aren't the numbers. That's just how you would convert percent to a decimal. Decimal is moving over 2 spots to the left or dividing by 100. Now, this atomic mass part, that comes from over here. So this will make its way all the way down here. So this is from the front. And with that, you'll have all the information that you will need. So then it will finally be time to calculate atomic mass. And so if we label this column as A, this column is B, and this column is C, if you're using method 1, you will need columns A and column C, the information in those 2 columns. When you use method 2, you'll need the info in column B and in column C. Again, here is the formula for you. Again, in case you haven't gotten to it in class yet, the formula is there. You should get the same answer both ways. So if you don't, go back and check your answers. Another thing to point out is that parentheses are huge. Do every little part of your calculation differently or separately so you have, that thing. Calculators can get confused very easily. Next, and your last question in this lab is calculating percent error. So it's telling you that the actual average atomic mass is this number. You are to use what you calculated in question method 1 and method 2 as your measured value. Again, they should be the same. So that's where that comes from. Again, your percent error formula is right there. Calculate your percent error. Again, do your things, your calculations step by step. You should be good. And for everything, round to 3 decimal places. That is, in a nutshell, your average atomic mass lab.